Welcome back, pyare bachcho. So good to see you again. Exams are just around the corner, I know. And today, we're going to master one of the most important chapters for your exams, limits and derivatives. So get ready, and hey, don't forget to subscribe and share this with your friends.
All right, let's start with a little puzzle. Imagine your favorite cricketer, maybe Bumrah, bowling a super-fast, toe-crushing yorker. Now, finding its average speed is easy, right? You just do distance divided by time. But what about its speed at the exact split second it leaves his hand? How do you find the speed at one single tiny instant?
So here's the big difference. Average speed, well, that's the total distance over the total time. Simple. But this instantaneous speed, the speed at a specific moment, that's the tricky one. And you know what? That is exactly what calculus helps us solve.
So, what's this magic tool that lets us find this instantaneous speed? Well, it's something called a limit. Now, I know the name might sound a little intense, but trust me, it's actually much simpler than it sounds.
Okay, so what is a limit? Let's just forget the textbook definitions for a second. Think of it this way. A limit is simply the value a function is heading towards as you get closer and closer and closer to a certain point. It's all about what value the function should have there, even if it's not actually defined at that exact spot.
Look at this table. It shows the whole idea perfectly. We have a simple function, f of x equals x plus 10. Now, look what happens as we get super close to x equals 5. From the left side, with numbers like 4.99, the answer is almost 15. And from the right side, with numbers like 5.001, the answer is, again, almost 15. See? It's approaching 15 from both sides. That is the core idea of a limit.
And that brings us to two really important ideas, the left-hand limit, or LHL, and the right-hand limit, RHL. You can think of it like two friends walking towards a cafe from opposite directions. For them to meet, they have to arrive at the exact same spot, right? It's the same for a limit. For a limit to exist, the LHL and RHL must meet. They have to be equal.
And this graph shows exactly what happens when those paths don't meet. Take a look. As we approach x equals 0 from the left side, the function is heading towards the value 1. But if you come from the right side, it's heading towards 2. The paths don't meet. So because the LHL is not equal to the RHL, we say the limit at x equals 0 does not exist. Simple.
Okay, now for something you are absolutely going to see in your exam. What happens when you plug in the value and you get 0 divided by 0? First thing, butchone, do not panic. This just means we need to do a little more work. There's a really simple way to handle this.
Just follow these three simple steps, okay? First, factorize the top and bottom parts. Second, you'll find a common factor. That's the little troublemaker causing the zeros. Just cancel it out. And third, just substitute the value again. And buzz, ho gaya, you'll have your answer. All right, let's put this into practice with a classic question you'll find in your textbook. We need to find the limit of x squared minus 4 divided by x minus 2 as x gets closer to 2. Now, if you plug in 2 straight away, you get 0 divided by 0. So time for our 3 steps.
See? It's so easy. Step 1. We factorize x squared minus 4 into x minus 2 times x plus 2. Step 2. We cancel out the troublemaker, which is the x minus 2 term. And finally, step 3. We're just left with x plus 2. We put in x equals 2, and we get 4. That's it. Easy marks.
Now, time for a superstar formula. Please put a big star next to this one in your notes. It's a huge time saver. The limit of x to the power of n minus a to the power of n, all divided by x minus a, as x approaches a, is simply n times a to the power of n minus 1. You must memorize this.
And here's another superstar, this time from trigonometry. This one is so important. The limit of sine of x divided by x as x approaches 0 is always equal to 1. You're going to see this pop up in a lot of questions, so make sure you know it.
Okay, so we've talked all about limits, this idea of getting infinitely close to a point. How does this help us with our cricket ball puzzle? Well, this idea of getting closer is the absolute key. Let's connect it all back.
The answer to our puzzle, that instantaneous speed, has a special name. We call it the derivative. The derivative is exactly what we were looking for. It's the exact instantaneous rate of change of anything at one specific point.
And this picture illustrates the whole idea so beautifully. Look, the line that connects two different points on the curve gives us the average speed. But now, imagine we make the time gap between those 2 points smaller and smaller and smaller until it's almost 0. What happens?
That line becomes a tangent, a line that just touches the curve at one single point. And the derivative? It's simply the slope of that tangent.
Now, bachon, this is the master formula of the entire chapter. This is called the first principle of derivatives. You absolutely must know this formula by heart. I can promise you, you will get a question on this. F dash of x equals the limit, as h approaches 0, of f of x plus h minus of f of x, or divided by h.
Okay, let's use this master formula right now. We'll solve a classic problem, find the derivative of f of x equals x squared using the first principle.
So we just follow the steps, we plug x squared into the formula, then we expand the x plus h squared bracket. Now, notice how the x squared terms just cancel out. That's what we want. We're left with 2xh plus h squared on top. Now we can take out h as a common factor and then cancel it with the h at the bottom. We're left with just 2x plus h, and as h becomes 0, what's our answer? It's 2x.
So there you have it. We have just proved that the derivative of x squared is 2x. See? It's just a few simple steps of algebra. Tension matlo. You can do this. Okay, pyare bachcho, that's a wrap. Here is your final revision checklist. Just make sure you are confident with these 4 key points. Number 1, a limit is all about the approaching idea. Number 2, a limit exists only if LHL equals RHL. Number 3, for 0 by 0 problems, remember the 3 magic steps: factorize, cancel, substitute. And number 4, memorize that first principle formula.
And that's it for our super quick revision. I really hope this helps. Let me know what you think in the comments. And here's a little something to think about. Now that you know how to measure instantaneous change, where else in real life do you think this is useful? Think about it. All the best for your exams.